Hello. So, it's popularly said here, if you have successfully followed lesson one, lesson two, lesson three, telling you you are doing well. All right. Yeah, you get it. That's fine. If you don't get the joke, that's fine. All right. So now if you're able to complete lesson three, complete variable. Trust me, you can do as much as possible. A lot with all the things you are learning and learning here. All right. So now lesson four, considering a few statistical tests, um, t-test, the ANOVA, the correlation, the regression, as much as possible. I don't like videos too long, so you can just get some rest, do some DIY, and of course, go move on to the next one. All right. So talking of t-test, maybe ANOVA. All right. So let's kick it. Let's start. All right. So now, to perform t-test is usually a test of means. Test of means. You compare between the means of two groups, maximum two groups. Yeah. So now, how do you do that? Come to analyze. Compare means. So here we have one sample t-test. Now, in one sample t-test, let me take before I even let me take product orientation, for example. And before I do this, I need to test some things. Let me just check a face value of minimum and maximum here. I have a minimum of 9, I can see 8, I can see 7, I can see 9, okay, minimum 7, and maximum I see 19, bit 19, so 7, 19, so I can postulate, I can hypothesize that the mean value for the, for this for the respondents in this study, the mean value for product orientation is 12. Yeah, let me choose 12 or 13. So here I'm going to say 13 as my test value. So I'm saying my process orientation, because I can choose more than one, but they have to be the same test value. So one is better. So I'm saying that for the respondents in this study, that's my hypothesis. The respondents in this study, let me state the null hypothesis, or let me just not over maybe I should not avoid with statistical terms. So I'll say it anyway for those who understand. My null hypothesis is that the mean of product orientation for respondents in this study is not 13. Now we have that's another complex thing to discuss. The not 13 means that it is either less or greater than, which is a two-tailed text. Alright. So what we are saying is it's not 13. Okay. So I say, okay, now I have my mean. The original mean is 12.5. The standard deviation, standard error. Now what I'm interpreting here mainly is my p-value, the significance rated. The rule of thumb is that whenever this p-value is greater than 0.05, I accept the null hypothesis and say I accept the null hypothesis. But if it is less than 0.05, then I reject the null hypothesis. Here, my significance rating, my p-value is 0.296. That means that I'm accepting my null hypothesis which I stated earlier that the mean of this sample is this study is 13. Now, my hypothesis is telling me, so you can see test value is 13. Now, my analysis is telling me that it is wrong, it's not 13. Another example we can relate to it is, there's an argument that, oh, Africans are short. There is sample Africans, of course, large enough sample size, and we perform a t-test. So a t-test is used for just, a one sample t-test, just like the name implies. It's just one sample, one sample. It has to be numerical, it has to be scaled, and you have an hypothesized value that you are testing. All right. So that's for one sample t-test. Now, another type of t-test functionalize compare means independent sample t-test. Now, for this independent sample t-test, we are testing the same thing but between two groups. Now, we've tested for the whole group that the process orientation is 13. Now, we want to test between two groups. The process orientation of male is it the same thing as process orientation for female? If there's anything you don't get, you can pause and rewind until you get it. So, the independent sample test now it compares between two groups, the same measurements between two groups. It might be checking height or weight or diameter of something, observation taken from your plants, and all maybe between two species, and so on. So let's do the process orientation. In fact, let's do process orientation, product orientation, technological, blah blah blah, work disposition. This four. So across which group? Sex. Oh, sorry, that shouldn't be. Sex. Okay. So define groups. Call them one. It has to be two groups. Once it is more than two groups, you can no longer use independent sample test. You can use ANOVA. That's when between independent sample test and ANOVA. For independent sample test, your factor or grouping variable has to be two, not more than two. But for one way ANOVA, you can have more than two grouping factors. We'll get there soon. So once this is done, I say okay. So here I have the group statistics, product orientation, male, female. Number we have 19 and 21. Mean for 19 is 12. Mean for male is 12, mean for female 13. Standard deviation, standard error of mean, and so on for the others. So if you come down here, so this is F statistics, this is okay, this is the Lavaine's test for equality of variance. I won't really be talking about that. Significant two-tailed is what we are interested in. So the assumption, the hypothesis is that the product orientation for male and female, that the null hypothesis is that is not the same. Is not the same. And don't forget, if our sig two-tailed, our p-value, if it is greater than 0.05, we are accepting. If it is less, we are rejecting. So here it is greater. I think for all of them, it's all greater. So we are rejecting the null hypothesis, which says that product orientation is not the same for male and female. Process orientation is not the same for male and female, and so on. But when we check this, you can say, well, it's the same. But but it's not the same. So why are we rejecting the null hypothesis? Now, if you check here, mean for male is 12.315. Standard deviation is 2.8. Then here also is 13. 3.11. By the time you do minus and plus standard deviation, check their lower and upper uh, level of confidence interval, you will see that they are interwoven. And that's why we have to say that, okay, they may not have the same exact meaning, but there is no statistically significant difference between their means. So we can't say what disposition of male is different. Uh, okay, we can say it's different because the null hypothesis is not different, and we are okay. We are accepting it that it's not different. Okay, so now we can make our interpretations accordingly. That's for independent sample t test. So let me recap. The null hypothesis is that the mean difference the mean, there's no mean difference, or let me put it in simpler English, the mean of male and female is not the same. It's not the same, there are differences. Now, our significant two-tailed p-values is telling us to accept that hypothesis that they are not the same. So 12.3 is not the same as 13.0. So you could be like, oh, it's obvious that it's not the same. Well, sometimes you can have results that they are that they are not the same, even though they are that they are same, even though they are wide apart. Okay. So if you have any questions as touching the hypotheses and all, you can read up and let me know when you have challenges. Alright. So let's treat the third T test, which is very, very interesting. Compare means. So we have PET sample, PET sample T test. We have one sample T test, independent sample T test. This is a summary independent sample T test. So it's a PET sample T test. Here, this is uh, quite interesting. Unfortunately, there are no variables you could use to test this. All right, maybe I can just create one sharply. Now, what's while I do that, while I'm trying to create two more variables to test this one. Now, I'm going to explain what paired sample t-test does. It's usually a test of before and after. So let's assume the people here, okay, like I said, this is a company, and the survey is on employees of a company to test what's actually affecting their work disposition. All right, so now a consultant was invited to test to give them training so that their work disposition can be improved. So the before the training, the company or the consultant wants to know how effective is their training. Before the training, the consultant gave them a test each, and over 50, let's say over 100, the score was this is their scores before the training. The lowest person had 15, the highest person had 76. All right, and they are 40. Wow. Okay, so I want to change for here. So after the training, the lowest person had 45, and the highest had 99. Okay, so voila. Okay, so now I want to I want to test the difference between their scores before the training and after the training. So let me go back to my SPSS variable view and add that variable there. So before training, I can have before training, after training, the scores after training. Okay, it's two decimals. I mean zero decimals. I don't have decimals there. Scores before training and scores after training. And this is skill, skill. Bring in hypothesize data from Excel. Control V. Alright, then I save. So now I have this their scores before the training and the scores after training, scores before training, scores after training. So now analyze, compare means paired sample t-test. So the null hypothesis here is that there is no significant difference between the scores before a test and after the test. Okay, now I have my paired sample t-test. It gave me also a correlation value. What is the correlation between the test before and after? And the correlation is quite low and is not significant. So well, here, paired sample test, I have my significant difference here. So now my null hypothesis that there is no significant difference between the scores before and scores after. Now, and I said the rule of thumb for rejecting or accepting hypothesis is that when your p-value is less than 0.05, reject the null hypothesis. When it is higher, you accept null hypothesis. So here our value is our p-value is telling us is actually lesser than 0.05. So we reject our null hypothesis and conclude that there is difference between the scores after and after and before. So to actually seek direction of, however, correlation is telling us that there is little correlation, which implies that it's not those who scored high in the test before, they are not the same people who scored high in the test after. Okay. Then scores before the mean is 43, scores after the mean is 71. That shows, well, our consultant has done a good job. You can also test other descriptives to see minimum and maximum. Okay, so let me just do that. So you can see the application of split file. So I'm going to split file. Let me see, can I? How do I want to do that? How do I want to do that? How do I want to do that? Okay, no, I don't have to do split file. I'll just do it separately. Okay, analyze descriptives. Okay, let me use. Have I used frequencies? No, okay, I've not used frequencies for compare. No, I've not used frequencies for scale variables before, so I'm going to use frequencies now. You see why I like using frequencies all the time. When it comes to statistics, you can see a whole lot of things that I can do with descriptives also, and maybe more. I have median here. I have quartiles, percentiles, standard deviation, center of dispersion, variance, minimum, maximum, standard error, range, a lot more than I have in the descriptives. That's why always so. But to get if you don't uncheck this, you get a messy output because I don't. It's so messy. I don't even like explaining it because this is a scale variable, and if you should tell it to give you this to display frequency table for a scale variable. Who knows? Maybe 15 appear just once, so it's going to give you one for a lot of these variables. So, well, if you don't get what I just explained, you can try it. Click the display frequency tables and see the sense you can make out of the frequency table. So I'm going to uncheck it and I don't want any charts for this here. No. And okay, all right. So now I see that my t test have told me that the difference between them is very significant. Yeah. So as the owner of the company, I can say, oh, this consultant really tried. Or as a consultant, I can show them, I can show my results to the my employers and tell them, oh, this is the results before we started the training. After the training, we came back some months or some weeks or immediately after, we gave them another test and their disposition to work has greatly changed. Now the question will now be, did it change positively or change in a negative way? So here the mean for before is 43, the mean after is 71, which implies positive. Now the minimum here before the training, the person that got least had 15. Here the person that got least had 49, I mean 46. The person that got minimum here had 75. The person that got, so of course as a consultant I will be proud of myself that I did a very good job training the employees of this company. All right, so I don't need this. I intentionally do not save them and I'm not selling it to you, but I want you to also try yours and have exact thing. So those are your DIY and fumble with other data you can lay your hands on. And I'll be glad to hear from you, to see your emails, see the works you have done, and put you through in anything I feel should be added. All right, thank you. So, well, for T test, thank you.